This is Software Engineering Radio, the podcast for professional developers on the web at se-radio.net. SE Radio is brought to you by the IEEE Computer Society and by IEEE Software Magazine. Online at computer.org/software.
Today I'm talking to Ashley Peacock. He's the author of Serverless Apps on Cloudflare, and he was a previous guest talking about diagramming in software engineering. Ashley, welcome back to Software Engineering Radio.
Hey, glad to be back and looking forward to talking about Cloudflare today.
For anybody in our audience who hasn't heard of Cloudflare, what is it?
So I guess Cloudflare's been around for quite a while. It started out as a kind of cloud security company. And then over the years, they've had different phases where they gradually grow from doing security related to websites, so bot protection, content delivery network, things like that. And they've slowly migrated to also introduce a developer platform that's not unlike AWS. So you can go on, you can deploy your apps, they've got everything you need. And those are the kind of two main pillars, I would say, of what Cloudflare offers.
And I think maybe a lot of people's first exposure to Cloudflare is as a CDN. So maybe you could explain at a high level what a CDN is.
Yeah. So let's say you have a WordPress blog and you host it on a virtual machine or some shared hosting. You're effectively hosting it on a single server. And let's say you're really lucky, you write a really positive blog post, it goes, viral, gets retweeted everywhere. Your little VM or your shared hosting might not survive the rush of traffic. And what a CDN can do is it distributes your content from your blog. So the images, the JavaScript, the CSS, and the content itself globally around the world. And then what happens is whenever a request comes in, the CDN will check and see if it has content in its cache. If it does, it will return it without ever hitting your VM. So that gives you decreased latency, so fast responses for end users. And it also puts a lot less pressure on your VM. And then with Cloudflare, they'll also give you some security protection to protect you from, attacks and, bot protection and things like that. So it's effectively like a proxy sitting kind of like in front of your website as a bit of a shield and just gives you those benefits that I outlined.
And you mentioned it's starting to become more of a developer platform. What do you mean specifically by that?
So if you go back to the origins of Cloudflare, it was a security company, the CDN we talked about, that's how it largely started. And the very kind of beginnings of its developer platform were allowing people who used the proxy to do things like modify the request headers before the content is sent back. So you could add a HTTP header, for example, or modify the response. And that was the very kind of beginning of what's called a Cloudflare worker, which is like a serverless function. You can write some code, be executed when a request comes in. And then over the years, they've taken what was something very simple to just modify the headers. And you can now deploy fully fledged applications to Cloudflare's developer platform. So workers give you compute, very similar to AWS Lambda in some ways, but also very different. And they have the other kind of core building blocks that you would expect to build applications. So databases, caches, queues, all those sorts of things that you use from AWS like R2 and Aurora and all those things. But it's a lot more focused than AWS. So AWS these days has, I don't know how many services it has, but it's in the hundreds, right? And Cloudflare focus on the kind of core building blocks for your website, I would say. And particularly in the last few years, they've really kind of pushed that developer platform and added what I would say are the kind of missing pieces. Like they didn't have a database, they didn't have object storage, but it's really come on leaps and bounds in recent years. And I think it's at the point where it's starting, you can start to see the momentum and people are starting to pick it up and realize actually it's a kind of complete platform for building apps these days.
And you mentioned workers as an example. It sounds like that's very similar to AWS's Lambda. Why would someone who, for example, is already on AWS look at something like workers?
I think one of the huge selling points for Cloudflare, in my opinion, is with Lambda, for example. Let's just take Lambda because it's probably the biggest one that everyone knows. It's been added to AWS, but they also have hundreds of other services. They've kind of bolted on serverless and Lambda onto their offering, and it works, very nicely. It's not a bad product by any means. But with Cloudflare's offering, they always envisioned their entire platform being serverless. So it's designed from the ground up to be serverless. Not only that, but they focused on things that are important to me and you with developer experience and how easy and enjoyable it is to build on the platform. Like if you've ever built anything on AWS lately, you probably spend half an hour trying to get your IAM policy just right because it keeps on not quite working. You tweak it. Eventually you get there, or you need it, and then you need a VPC, or you need an IP address or something. With Cloudflare, there's no such roadblocks. It's more like the platform is kind of working with you, and they've really designed it for engineers versus AWS to a point has to kind of build and market to the CTOs and people that are not building those products, right? Whereas Cloudflare, I think, has taken a slightly different approach.
What it sounds like is maybe the developer experience or the ease of use is more optimized on Cloudflare than it would be for someone getting started with AWS.
Yeah, I can give you a couple of examples. So I think things that you don't get generally in other places. So let's say you want to connect your worker, so your kind of serverless function to a database or a cache or any of the resources that Cloudflare gives you. You use what's called a binding. And if you've ever used dependency injection, it's kind of like automated dependency injection. But rather than you doing it yourself at runtime when your worker is started by Cloudflare, because a request comes in, your worker is invoked and spun up automatically by Cloudflare. The request is executed against it. And at that point, they will inject the binding that is needed to run your worker. So if you have access to a database, it's just injected for you and it's effectively in the environment for you. You don't have to mess around with secrets or any configuration. It's just there for you. And that also then flows in, and this is kind of what I was talking about with the integrated nature and the developer experience of when you run your worker locally, Cloudflare will use their kind of local emulation to spin up effectively kind of like stubs that are faking. They're not running against real resources. You can just run that locally and you'll get the exact same experience as you would in production. But you've had to make no changes. You can just run a single command. It will start your worker. It will have access to all your bindings, however many there are, and it will just pieces together very kind of seamlessly.
I'm trying to understand how the binding works in practice. So with a traditional application, if you had a database, you would need, let's say, credentials or a connection string. And like you said, you could put that into some kind of secret store or environment variables. How are the bindings different? What does my code actually look like where it can find how to connect to the database in this case?
Yeah. So you first, because everything is serverless, you create the resource you need, and Cloudflare have their own CLI called Wrangler. So if you're just hacking together something, you can easily just run a command with Wrangler that will make you a database or a cache or whatever you need. It will basically give you back an ID, or sometimes you use the name of the resource that only your account has access to. And then you take that ID or that name and you put it in a configuration file that's historically been in TOML, but you can now use JSON, and it's effectively just, your configuration goes in a JSON file. And then at runtime, Cloudflare reads that file and it injects the correct one. And in that configuration file, you have things like environments. So you can have, obviously, you don't want to have your staging and production databases to be all mixed. So you can effectively spin up multiple databases and configure the correct one for each environment. And then, when it's run at runtime, it'll be injected.
So the distinction, I guess, is instead of having references to a specific host name or IP, you are putting in this ID into your configuration, and then Cloudflare is figuring out where that database or that other service actually is.
Yeah, correct. And then in your actual code, there's a parameter on your worker. If you're using a framework, they'll have code that the framework has written that makes it accessible, but it's effectively like it being in your environment for you. And you don't have to worry about how you interface with it necessarily, because they will inject like an SDK for you to use. Each of them comes with an SDK. There are wrappers from the community that obviously enhance them, but generally speaking, all the kind of core functionality is wrapped for you in an SDK that's injected for you at runtime.
And you had mentioned the local development example. So it sounds like if you're running locally in that config file, there's something you could put that tells it, instead of trying to connect to my production instance running on Cloudflare, instead run this local emulator and connect to that instead?
Not even that. It will effectively, when you run the command by default, it will just run and emulate everything locally. And then if you want to run it remotely, you can actually run them remotely by effectively just passing in a flag when you run the command. And then it will effectively push your worker into like a sandbox environment. So it doesn't deploy it to like your account. It's in a kind of safe sandbox environment, but it has access to all your bindings. So let's say, I don't know, you're finding it difficult to debug an issue in, let's just say, staging, right? Because, staging, you can mess around with the data. It's not user data. You could easily run that worker locally, point it at the staging database and run everything locally, and then try and replicate yourself super easily, which I think is super nice.
So what this would look like is you have your project with all your source code files, and you use the command line tool, that Wrangler tool, and based on which flags you pass in, it either will emulate the dependencies by default, or like you said, you can pass in a flag and then it will actually run it on a server instead.
Yeah, that's exactly right.
I'm trying to just make sure I understand the binding part specifically. When you say things are being injected at runtime, like what exactly is being injected? Like what do I see in my code, and then what is actually going in at runtime?
So each worker has an entry point. So if we just take a bare bones worker, the function is called fetch, and it has a few parameters on it. One of them is obviously the incoming HTTP request. So you can pull out the URL, the headers, whatever you need. And then the second one is basically literally called environment. And on that environment, when you're configuring it in your Wrangler file, alongside the ID, you define a name for the binding. So, you give it a descriptive name for whatever it is, if it's a database or a cache or whatever. And then you basically do environment dot the name, and then you can just call methods on it. So let's take a cache. Very simple, right? With a cache, you can set, or you can get, or you can delete and maybe list. You basically just call those methods on the environment, and it will execute those remotely against whatever the binding is for, such as a cache.
In your configuration file, that TOML file or that JSON file, that's where you create these environments and you specify what services or resources you have available. And then in your environment parameter, you can access all those things you put in your config file?
Yeah, and Cloudflare will just effectively read that configuration file and inject all of those at runtime seamlessly.
We talked a little bit about workers, which you said are similar to Lambdas. So those are serverless functions. Since serverless is sort of an overloaded term, can you sort of explain to people who aren't familiar with them what that really means to you?
Yes. So as you said, there are many definitions for serverless. So if you ask 100 engineers, they're going to give you a different definition. I think for me, there are kind of some core tenets of what makes serverless. I think one of the main ones is that you pay based on usage. So there are some services from AWS, I think Redis is one of them, where it has like a base cost. So even if you're not using it, you have a base cost. So it's not scaling to zero. And for serverless, it should scale to zero. You shouldn't need to do any maintenance. So you shouldn't need to upgrade the version of the programming language or the software you're using. Or if you're using, let's just say, keep with Redis, you shouldn't need to upgrade your Reddit version. It should be handled for you by the platform. And you shouldn't need to wait for your resources to spin up, because you're not spinning up a server. So the whole thing about serverless is it should be quick. And that's exactly what it is with Cloudflare. If you issue that Wrangler command to create a database, you're kind of creating a logical database rather than an actual physical instance. And that is available instantly for you to use. So I think those are some of the key things of when it comes to serverless, what I would consider it serverless to be.
And something I used to hear about often is what people refer to as the cold start problem, where it takes time for the resource to be available. Is that something that you also have to be aware of on Cloudflare?
No. So there are exceptions, as with all things. But unless you have a huge worker that is perhaps doing something on boot, you will generally never see cold starts with Cloudflare. And the reason is the runtime is very different to what you can run on at least the typical Lambda. Cloudflare's environment is their own runtime, and it's based on the same runtime that you run in Chrome. So it's called the V8 engine. It's exactly what runs in your browser. So that makes JavaScript kind of king. At least JavaScript and TypeScript are the primary languages that are supported. You can also use WebAssembly to then compile from pretty much any language with good WebAssembly support. Rust is a big one because Cloudflare internally use a lot of Rust. And then that runtime is also enriched with Node libraries. So it's not full Node, but it's got kind of compatibility with a lot of Node, especially recently. They've been really adding the kind of compatibility to it. But in terms of the cold start, what they do is quite clever, where when a request comes into your worker, or really if a request comes into anything in this day and age, it all goes through HTTPS, and it needs to do what's called a TLS handshake, where the client basically, they exchange certificates and they do a handshake, and it basically verifies that the connection is secure. And that takes, I don't know how long it takes, but it takes some milliseconds, where in that time, Cloudflare basically knows where the request is going, and it's warmed up your worker while it's doing that handshake. So that the time the handshake is finished, let's say it takes 50 milliseconds, your worker is then able to handle that request instantly, and there's basically no cold start. And that's thanks firstly to what I just explained with the handshake, and secondly with the runtime, because you can imagine you open a tab, each one of those is its own V8 runtime, and you can see how quickly your tab is available, right? It's available instantly. So I think it's a mixture of their technology stack plus some clever engineering.
It sounds like, so maybe that's one of the trade-offs between the Cloudflare workers and Lambda, where I believe with Lambda, they have specific language support, and it's not specifically tied to can it run in WebAssembly. Whereas with Cloudflare, it sounds like if you can compile to WebAssembly, then you can run it.
Yeah, I would say the vast majority of code at the moment is written in JavaScript and TypeScript for sure, because that's, as you can imagine, it's basically like a browser, so it natively runs out of the box. There was Python introduced towards the end of last year or earlier, last year, which is natively running, but it's not fully there yet. I think you can see the direction they're going in, but things like dependencies don't quite work that well yet, but I think more will come. And certainly Rust is one of the main ones because it has the WebAssembly support, but it's for sure a trade-off where on AWS, you can have a full node environment, for example, or you can have Ruby or whatever else that they support on Lambda.
And something I've heard about WebAssembly is that there are certain limitations where you can use these languages, but certain IO level access, for example, is maybe not available. Does that also apply on this environment?
It does. So whether you're using WebAssembly or using JavaScript, you actually don't have access to the file system, same as in the browser, because you have the same kind of restrictions that you have in the browser. So if you're reading configuration files, you can't read those from the file system because you just simply don't have access. You'll need to push them to object storage, or if the configuration is quite simple, particularly in JavaScript, you can obviously just define objects and have the configuration defined in your code. But yeah, the restrictions that you've probably encountered probably apply here as well, I would say.
So we've mostly been talking about workers, but AWS, as you mentioned, has hundreds, if not thousands of different services. I imagine Cloudflare doesn't have quite as many, but there's still probably a lot. What would you say are the core services to focus on outside of just workers?
So you have R2 from Cloudflare, which is basically an S3 compatible object storage. So if you want to store user-generated files or your own generated files and have them served from a bucket, it's completely compatible with S3. You can even just port all your content from S3 into R2 and use the AWS SDK, and everything will just mostly work. There is a few kind of little APIs that aren't implemented, but generally speaking, it will work. And the nice thing about Cloudflare is that it has no egress fees, unlike AWS. So if you're doing a ton of egress via S3, you could move that content to R2 and you're not going to pay egress. And it might save you obviously a lot of money because the egress costs they're kind of like a bit of a hidden cost, aren't they? Where you're not really, it's kind of hard to work out where it's coming from sometimes, and they can really rack up. For a worker or R2, you don't get charged egress. Besides R2, you have D1, which is their serverless database that's effectively SQLite. They're a little different to things you'll find on AWS because they're designed to be per tenant. So they're limited in their kind of size, if you will. It's not you're meant to have one database per user. You have multiple databases typically. They have a key value store. So its interface is similar to Redis, but its kind of design is quite different. It's designed for kind of read heavy rather than write heavy. And it's eventually consistent rather than Redis. So it's obviously just, it's real time, sub-millisecond. But it's also, Redis is hosted in one location. It generally sits close to your application server, right? Whereas with Cloudflare, everything is global. And I guess, like we were talking about trade-offs earlier, one trade-off is because it's global in nature, there are these eventual consistency concerns where you write, it'll take a while to propagate around the entire network. In terms of like hosting your static content, because until recently at least, workers were primarily just for handling APIs, and you could do content, but it was much more common to use a framework. So you can imagine Next.js, Astro, Svelte, all the popular JS frameworks are deployable to Cloudflare, and they have a product called Pages, and that effectively is just your full stack hosting where it will serve your static assets, and it will also convert your Next.js routes, for example, if you're using Next.js, it will convert those to kind of effectively like a worker at build time, so that it works with Cloudflare's platform. So that allows you to host your front end. And more recently, you can also host the assets with workers too. Those are some of the key ones, I would say.
And when you mentioned how D1 is like SQLite, but it's really designed to, I think you said it's almost like having one database per user. Is that because the size of the database is limited and the I/O in terms of simultaneous writes and reads is limited? What are the limitations or differences in design there?
The limitation, I think, is probably exclusively the storage. So I think they're limited to 10 gig, which obviously per user is probably generally fine. But if you have thousands, 10,000s, 100,000s of users, it's not going to scale to meet that demand. So yeah, it's definitely designed in a way that it's split by tenant or user or some sort of other configuration. In terms of like what I would use, I would probably use an external database for now because it doesn't have things yet that it needs. Like at the moment, bindings are static. So imagine you create 10 databases with 10 different IDs. It becomes really difficult to bind those. So you could add a binding for every single user, but if you have 10,000 users, it's going to be a lot of bindings. I don't think they're going to let you even bind that many things. And secondly, like I said, everything is global, but with D1, the database is created where you first make the request, or you can give it a suggestion of where you want it to be created, so Europe or North America and so forth. And I think this year, read replicas will drop, so then you'll have a truly global database. And there have been murmurings of like dynamic bindings, which you would imagine would be something useful for this. But I think at the moment, a lot of people that are using Cloudflare are using other database providers because it's easy to connect to. Neon is a really popular like Postgres serverless database. You can connect it to any serverful Postgres database such as Aurora, and they have a product called Hyperdrive that's quite cool because you can imagine if you're in a serverless environment, those functions are spun up and spun down all the time. And if you have like a connection string, it takes a while to connect that database. It might take 500 milliseconds to connect to that database. But with Hyperdrive, it basically creates connection pools. So Cloudflare will do it automatically for you. So rather than each time you're having to connect to your Postgres database and handle the security and everything, those connections are ready to go. So that removes that problem. And I think it's a really nice solution to allow people to use external databases with Cloudflare that, like I said, most people, I think, tend to use external ones for now.
And with that Hyperdrive example, would that be where you create a database in, for example, in AWS, and in your TOML file or your config file, you are specifying your connection string and all that stuff, and you're saying that I want Hyperdrive to connect to my database, then at runtime, your application will know, okay, I'm connecting to Hyperdrive to do this and not directly to the database.
Yeah, exactly. So it basically works out of the box. So you don't need to change anything, like obviously apart from configuring Hyperdrive, but it will run the connection pools for you. And with a little bit of configuration, you can use all the SDKs you would normally use because it's just pooling and effectively proxying the requests. So yeah, from what I've heard, at least it's out of the box. You just plug it in and it'll work.
And with the key value example, you mentioned that it's like Redis, but it's more for read-heavy workloads. What's the limitation on writes? Is it just it can only accept a certain amount per second?
In terms of writes, you can write unlimited times per day once you're on the paid plan. That's just $5 a month. And in that paid plan, you do get a lot. And you can write to the same key once every second. But the issue is more, it takes 60 seconds for that write to propagate. You can imagine you're using Redis, right? You often write, read, but that's just not going to work. And if you have users around the world, so like if I make a request to a worker, for example, we haven't touched on it, but that worker is spun up as close to the end user as possible. So if I'm a request, I'm in London, it's going to spin up that worker in the London data center. And then wherever you are in the US, it's going to spin up a worker in the US close to you. And the latency will be much quicker than if you're hosting it in an AWS region where we both have to go to different places. Maybe, I have to go to America or you have to come to Europe. It's higher latency. But what you have then is when data is written, let's say to KV, if your worker is in the US, it's going to write to KV in the US, and then it's going to have to propagate around the whole network. So if I then 1 second later go and access or read from the exact same key, I might get the old value, not the new value. So it just makes it a little bit difficult to support like high write workloads. It's designed really as like a heavy cache where you're infrequently writing, I think is what it's designed for. And I think it was one of the first kind of products alongside workers, because I think people were doing things like auth at the edge where, you can write someone's JWT or whatever into the cache and then it's just in there. And that's something where if someone's like, firing through pages, page after page after page, you probably want to cache that content. And that's really heavy read write because you log in once, you write the token. Jobs are good. That
60 seconds for propagation, when you perform the write, and let's say that you use the auth example, somebody gets their JWT, it's written to the key value store that's close to the user. I'm assuming that should be reflected pretty quickly. The 60 seconds you're talking about is more that if that cache is read from another country, for example, maybe that read replica, I guess you could say, that may not have the update for up to a minute later.
Yeah, that's exactly correct. And that's primarily because there is effectively like tiers within the cache. So within a country, you might have multiple different data centers, and each one of those will have their own kind of cache. And then you might have a regional kind of central data center, where it's like the next tier up. And then you have the kind of very central, the kind of really big data centers that are like the central stores. That means the worker is going to write. When the writes happen, they need to go to that central store, right? So they're also a little longer latency because it has to go to one of those central stores. And then from there, it propagates across the entire network.
Yeah, I can see that being a little bit tricky for you as a developer, where you have to account for the fact that anything you do write, if it's the same user who wrote it, reading it back, you have a much higher chance of it being updated sooner. But since you said it's eventually consistent, there's no guarantee that it will.
Yeah, that's exactly right. So it's just one of those considerations you have to have when you're using it, that's, if you went in and you see people like, they're expecting Redis and it's not Redis. And if you don't read the docs and understand, then it's going to be a bit of a shock when you write and you're building something and you send it to your friend and they're like, oh, something's broken, like it's not getting any data or something. And it might take you a while to work out unless you understood.
Does that also apply to D1, the SQLite equivalent as well?
No. So at the moment, when you create a database, that database exists in a single location. So all your writes are going to that one database, if you like. So this year, I think they will introduce read replicas. And I don't know how long the latency will be. They haven't really kind of said. But I suspect it will be a lot lower because you can imagine for a database that's designed to be more transactional, you can't have 60 seconds for a write to propagate. So my assumption would be that the latency is going to be a lot lower. And even with Postgres or whatever, right, there is some latency with the read replicas. So I assume they've factored that in and it will be, I don't want to say it's going to be because I haven't seen, but I'm hoping it's going to be what you'd expect when you have a database with read replicas and that sort of latency that's pretty typical.
So at least for the moment, since there aren't the read replicas, you should be able to treat D1 as if when you make a write, it actually went to disk if you were using SQLite as an equivalent.
Yeah, for sure. And there's definitely use cases for D1. I think if you know your data is not going to be huge, or I don't know, let's just say you're processing some asynchronous workloads, the data is very temporary. Maybe you write it and then you delete it. Maybe you've got some messages flying around because I think we didn't talk about it earlier, but Cloudflare has a queues product where it's effectively sending a message into a queue and then you can have consumers pull from that queue. So maybe you have some sort of transient load where you can push that data into D1, or if you just know your data is not going to be really huge, it's perfectly fine. So I think there are use cases for it. I think what I would say is if you are going to use D1, because we talked about the database is central and the workers can be spun up anywhere in the world across 330 cities that Cloudflare's in. and they have a clever little tool or configuration called smart placement. And what that effectively does is, and this doesn't work just with D1, it works with anything. So let's say you spin up something in a worker and you have something hosted in AWS database, or even just hitting like an EC2 image, or even just hitting like an API from a SaaS, like on your backend, maybe like Open API or whatever it might be. What smart placement does is it learns over time as requests come in what you're hitting downstream, and it records the latency. And over a period of, let's say, 24 hours, it learns your traffic patterns and what you're hitting, and it'll basically move your worker and spin them up in the most sensible place to reduce the latency. And that's because you're then moving the worker away from the user, perhaps. So they might have a slightly higher latency to get to the worker. But if that worker is then making 5 calls to the database or 3 calls to some APIs that are all hosted in, let's say, America, and your worker's in, the person's in Europe, putting that worker closer to those downstream services is going to reduce the latency because it's talking a lot more to those services. So I think that's a really nice thing that you can use, and there's no harm in enabling that, and it's completely free to use alongside workers, so there's no downside to using smart placement.
And that smart placement, would that apply to all your users? Basically, like if I have users in Europe and users in the US, you were talking about how smart placement may move the workers closer to where the data is stored versus where the user is stored. Is that sort of applied globally, where regardless of where I'm connecting in the world, smart placement may decide, oh, I should put this worker in Virginia because that's where the data stores it's connecting to are?
Yeah, it will effectively just monitor all the traffic going to your worker, which obviously, I guess it depends on your app, but it's likely to be from multiple places, and then it will work out after it's learned, and obviously it might adjust over time. So your app changes, right? So it's not static. So if you remove some API calls or whatever, it's going to learn. But yeah, it will adjust for global.
And you mentioned how there's R2, which is very similar to S3. Are there any large differences between the two that people should be aware of?
I don't think there's any huge differences. I think if you use some of the more niche S3 kind of features, then there is a page with compatibility on that you can look up to see what's not implemented, but they are definitely like quite niche. Things like pre-signed URLs, for example, you can do those with R2, and it provides, I want to say, the exact same kind of resiliency and uptime guarantees that S3 has, which I think is something stupid like 11 nines or 9 nines. I don't know how many nines it is, but it's a lot of nines. And I think R2 provides, or at least claims to provide, the same uptime that S3 gives you. So I think probably for 99% of usage, or maybe 98%, who knows, but a very high percentage is going to be, you could lift and shift, and it's probably going to work out of R2 rather than S3. And then you save on the ingress. And if you did want to move, there are some tools from Cloudflare to help you move. They kind of have funny names, but one of them is called Sippy, and it's effectively like an in-flight migration. When something is requested from the R2 bucket, if it's not in the R2 bucket, it will pull it from S3 at that point in time, and then all future requests will come from the R2 bucket. And then they have one called Super Slurper, which effectively is just like a mass migration tool. So it'll pull all of your data out of S3, put it in R2 in one big kind of batch. So there are some useful migration patterns to help you move if you want to move, because I think one of the challenges that Cloudflare has is obviously AWS has quite a moat. And one of the trickiest things, right, of moving an app, if you want to move, is the data, right? It's not normally the apps that are hard to move, it's the data. So I think having those tools, at least for R2, to help you migrate is definitely useful.
You mentioned there's a queue product as well. Is that something you see a lot of people using, or is that more niche or early?
I don't know how widely it's used. I don't think it's niche because it's obviously, if you can offload something asynchronous, right, it's kind of nice to do. And I think if you didn't have a queues product, there'd be some kind of raised eyebrows of, how do I do anything asynchronously? You just can't. I think that's a no-go. I think what's interesting is in beta at the moment, there's a product called Workflows. And a really kind of popular thing that's been around lately is durable execution. So if you think AWS step functions, or I think it's temporal IO, and effectively what it is you lay out a list of steps that you need to complete a workflow. I don't know if this is universal across the board, but generally speaking, they will recover from outages without losing where they are in the workflow. So if imagine you have 10 steps and it gets to step 5 and you need to call the downstream API, if the API call fails just because they have a momentary blip, it will effectively retry the workflow, but it won't rerun steps 1 through 4. It will jump straight back to 5, and it will basically store the data in cache if you have transient data and pull it out automatically for you and run through that workflow. And I think it's really becoming popular because of things like AI and agents. And you can imagine these kind of long-running processes that act as workflows. Like if you want an AI agent to write a blog post, right, I saw someone building one that's like hundreds of prompts and hundreds of requests. And if one of those just fails, you don't want to reprompt 100 failed requests, and it's going to be a bit of a nightmare. So I think the interesting thing is that workflow product, I think, is getting a lot of usage, even though it's only in beta. And I can see it taking a kind of quite a market share from queues, but it's not really designed you think about a queue, it's more kind of transactional in that you're having inter-service communication with queues versus workflows is kind of just safely offloading and being able to recover from failures and that kind of thing. But yeah, those two are definitely quite interesting.
Yeah, I think one of the reasons I asked about the queue is I think anytime you have something where you're running things like the functions as a service, you often need to have a lot of different services talk to one another. You need some kind of queuing system. And it feels like that has to be pretty robust, and that has to be able to be done in a way that's like not super complicated or super confusing. And so I'm trying to get a sense of either with your own projects or projects you've seen from other people, are they using Cloudflare mostly for, let's say, the CDN aspect and the serverless functions aspect, but not necessarily to chain a whole bunch of things together and build some kind of more complicated workflow?
Yeah, I would definitely say the CDN aspect is their bread and butter, because that's what they start out with. Huge enterprises, like the biggest companies in the world are using Cloudflare for their CDN. So it's definitely the most premier product they have. But I think their dev platform is at the point where it is starting to get traction and gain some market share. Like if you look at the Stack Overflow, the developer survey they do each year, you can kind of see that Cloudflare is slowly moving up. If you go back 5 years, it just didn't have the maturity around the products to realistically challenge AWS in terms of deploying your applications into Cloudflare. I think in terms of queues, I don't think I can speak to like how often it's used. I don't think I have a good read. I have used it myself and it works very nicely out of the box. And I think it definitely is easy to use. It's just writing a message to a queue, and then you basically have a worker that is basically acts as a consumer. And it's as simple as defining a function on your worker. So like the fetch function is what is used for HTTP requests. And then you just define a separate fetch function that I can't remember what it's called, but it basically it's there. And whenever a message is received, your worker is spun up and it will consume those messages, and Cloudflare will handle things like scaling the consumers. So I can't remember the limits, but it will scale your work horizontally based on demand, which I think is a really nice feature out of the box. You don't have to worry about things like Kafka and like partitions and all that kind of, fun stuff. You don't have to worry about any of that. And when we talked about local dev, if you want to test this locally, again, you don't have to go and find a Docker container for Kafka and spin that up and then connect everything together. You can just test it locally and run those two workers or run them in the same worker, however you want to do it. And you'll be able to see your messages go into a queue and then be consumed locally, which I think is a really nice kind of DevX thing that we were talking about. And you were talking about, I think, inter-service communication, right? Being in a microservices architecture, for example, you have lots of services talking to each other. And when we talked about bindings earlier, we didn't really talk about service bindings, which are how different workers communicate. And there are different flavors. The kind of like older version that's still very much used is you can define a binding between two workers. Then those workers can communicate with each other. And in terms of your code, you call fetch, which in JavaScript is just basically making a HTTP request. And it looks like it's making a HTTP request, but under the hood, it's not really. It's using Cloudflare kind of internal networking magic to basically run the two workers probably basically side by side, and there's no actual networking. So it's super quick, it's super reliable, and you don't have the typical fallacies of cloud computing that you often, hear touted about. The network's not reliable, bandwidth's not unlimited, so forth. There are obviously still concerns, but they're not as such a big concern because you're not going over the internet, right? You don't have the HTTP networking. And more recently, to make it even more interesting, is they introduced the ability to do RPC. So you can, again, connect two workers together, but rather than using the fetch method, where you have to like serialize and deserialize JSON on both sides, you can actually just effectively call methods on between two workers. And as long as what you're passing is serializable in JSON, so objects, strings, numbers, etc., it looks like you're making a local method call, but it's actually calling your worker that's completely deployed separate. And then it obviously returns you something that is serializable. So it might return you an object. It can even return you like functions that you can then call. It really is quite cool.
Yeah, so it sounds like for the service-to-service communication, whether it's the fetch replacement or the direct RPC or the queuing system, there are the building blocks for somebody who wants to have these more complex scenarios.
Yeah, absolutely. And I think it just makes it easier, I think, like having these. I don't know if you've come across these kind of things before, but when I tend to speak to people, they're like, oh, that sounds like, they haven't heard about these kind of things before. Because I think those service bindings, and obviously RPC is not new, right? But the way that it just is kind of built into the platform, and you don't have to do anything, right? You don't have to configure the RPC or anything. You just say, connect this worker to this worker in some configuration, and Cloudflare handles the rest. So I think it's very powerful.
And something I think you mentioned before the call that you thought was unique to Cloudflare and something we should talk about are durable objects. Can you explain what those are?
I'll try my best, because I think even if you sometimes speak to someone from Cloudflare, it's one of those things they struggle to market, I think, sometimes, because it's tricky. But you can effectively think of a durable object as it's like a class that you define in your code. So it looks like a regular JavaScript class, and you write them, the methods as you normally would. But what happens is, when you create an instance of this class, or when Cloudflare creates an instance of this class, we're using that RPC technology we just talked about, you're effectively acting on something running on their web server. So you can think of it like instantiating a class, but you're doing it with Cloudflare's SDK, and it gives you a stub, and all the methods that are called will be calling kind of an instance of that class that's on Cloudflare's data centers. But it's durable. So it comes with built-in storage. So it has a key value store. It's not KV, it's their own little key value store. And it also has a SQLite database in there as well. So it's sort of like, imagine being able to deploy on demand, because you can spin these up in milliseconds, right? You don't have to deploy them ahead of time. It's effectively like being able to deploy billions of tiny little mini servers around the world. And when I say billions, it's because when I've spoken to some people at Cloudflare, there are literally some customers who have literally billions of durable objects. And the nice thing about it is, because Cloudflare's platform is serverless, even though you have these, mini servers, you're only charged when they're running. So if you make a request, it runs for 2 seconds, you get charged for that 2 seconds, and then it will be evicted from memory and you don't get charged anymore. And I've never heard of anything like this anywhere else. And what they were initially kind of marketed at is a way for multiplayer real-time communication, like, Google Docs, that kind of stuff, because they also have WebSockets built in, and WebSockets are quite complicated, but it effectively implements everything for you that you need to do for WebSockets. And it has all these nice little features like storage, WebSockets, and it's very unique. I've never come across anything quite like it. So it is hard to explain, but hopefully you got it.
So when you mention it has the WebSocket support, are these durable objects things that the client, like the browser, would be able to interact with directly, or is this for interacting from workers?
No, so I don't know if you can actually do it from worker. That's an interesting one, but it's definitely mainly used from the client. So what will happen is you will call a worker, and that worker has a durable object binding on it. And all that binding is you basically tell it the name of your class that's defined in your code. And then when you want to create a new instance, you just call it a function on that binding and say, hey, give me a new one with this ID. So you could create, let's take Slack or, Discord or any of these kind of chat-based applications. Each channel could effectively be a durable object. So let's say you're logged into Discord already, because that's not handled by durable objects or anything, and you want to join a brand new channel. So you go through the list, you find one, you click on it, and you hit join. And at that point, you need to be able to receive messages from that channel, right? And that's all handled by your durable object. So what will happen is, on the client side, it will make a request, and in the browser, there's a library for handling WebSockets that just ships with the browser. And you basically give it a URL, and you can pass any parameters you want. So in this case, it would pass the channel ID, for example, which in Discord is like a long number. And let's say we're using that channel ID to effectively key our durable objects. So for every single channel that exists in the entirety of Discord, there is a durable object that represents that channel. And when the client makes a request to the worker, it basically says, is the client trying to upgrade to WebSockets? And that's basically like a HTTP header that is just set on the client automatically when you request a WebSocket. If you're creating a brand new channel, you'll obviously need to create the durable object. But let's say it already exists and you just want to join an existing channel. You basically say, durable object, create me a new one, and pass in that channel ID as its primary key, if you like. And then what the durable object will do is it will create a client and server WebSocket pair, because when you're dealing with WebSockets, there's always a client and a server, and they communicate with each other and they have a connection. The durable object will effectively accept the server-side connection, so then it can receive messages, and it will pass the client WebSocket back to the client. And then again on the client also accepts the WebSocket. And then when they're both accepted, they're connected. And then let's say, okay, I've joined the channel and I want to say hello. So I type in hello, press enter. And effectively on the client side, again, we're just using the browser APIs that come with WebSockets. I think you just call a method called send WebSocket message or something. And you can pass whatever you like in there. So you can pass a string of hello, but the chances are you probably want to send a bit more information, like who sent the message and all that kind of jazz. And then when they send that message, you've defined a function on your durable object that's automatically called by Cloudflare whenever the client sends a WebSocket message to the server. And then your durable object will be like, oh, hey, I've got a message. It'll wake up. It's got built-in storage. So let's say all the storage is kept in that durable object. So you can create, SQLite tables to store all the messages. So you'll probably want to write it to that storage so that when the next person joins, right, it can retrieve the history and send the most recent messages for people that joined after initial messages are sent. And then it can obviously broadcast it to everyone in that channel. So let's say there's 100 people in that channel. The durable object keeps a list of all the clients that are connected. And you can basically just retrieve that list of clients, loop over them, and just broadcast that message. And that's fundamentally how it works, at least for WebSockets. It sounds a little bit complicated because there's obviously lots of steps, but like if you implement it in code, it's really simple and it's really a really small amount of code.
And that particular example was with WebSockets, but it sounds like you can interact with them using HTTP calls as well, just regular ones.
Yeah. So I think durable objects are a way of representing business entities, if you like, in your application. And a really easy example might be, let's say you are handling support cases. So, imagine you're using AWS or using any service out there where you hit a problem, you need to submit a support request, right? And the traditional way to do that will be, you might have some database tables and all that jazz. It's all stored there. But with durable objects, each time a new case is created, you can basically create a new durable object. You can, have the storage within there, and then you can just define some methods that your worker calls that interacts with that kind of entity. And it kind of just wraps everything nicely in a bow. And because you can do things like WebSockets, although you don't have to, like I said, you could just have this working on regular HTTP, for example, and just, you press the submit button, it sends a post request, it calls the worker, so on, and the durable object. I was playing around with something the other day where a lot of these tools are email-based, right? You send an email to an email address. A nice little bit of functionality you can do with Cloudflare is you can ingest programmatically email. So you can have a worker that fires when you receive an email. So you can imagine you have a support email, you trigger this worker, it creates a durable object, and then you can ping pong messages back via email. But what I was also able to do is there was a link in the email that allowed them to do live chat, and they just press the link, and then it has an ID for the durable object. And then you can switch from email to live chat just like seamlessly, and everything is encapsulated within this durable object. And you can, as I said earlier, spin up an infinite number of these things pretty much. So they scale massively, and it kind of changes a little bit how you think about building your applications, just because it's quite different to have this kind of functionality, if you like.
Yeah, so it sounds like you have this SQLite store, this key value store, and you can have all of your clients share these objects. Any client who needs to have access to the same information, like the example you gave was like a Discord chat channel. Everybody in the channel would want to see the messages that other people are sending, so they would all be interacting with the same durable object. I think what some people might be wondering is, earlier we were talking about D1, which is the SQLite offering, and KV, which is the key value store. What's the distinction for people who want to store data and share data between using those services and using durable objects?
I think my opinion on it would be that the durable objects, you can probably imagine they're a little bit tricky to grasp. So I think KV was there because it was the very first thing that they built to work with workers. It's definitely still heavily used for like those high read cases. But I think if I was going to start a brand new project and I was going to reach for something that I wanted to like store my data, and like I said, with D1 at the moment, you need to split by 10 and it's a bit difficult to do. But with durable objects, like I said, you can spin those up on demand. And I think they actually have higher storage. I think you can store 50 gig in a durable object, which obviously, if you're thinking about a list of chat messages, that's a lot of chat messages. And obviously, you can have things in place where it archives off data and stuff, right? Because if you think about Discord, how often do you need messages from like 6 years ago? Probably very infrequently, right? I think D1 is there. I wouldn't be surprised if it's there to make people feel comfortable, because when you think about, imagine if you didn't have a database, like you went to Cloudflare and there's no database, you'd be like, they've got everything, but where's the database? And if you didn't twig they have this powerful durable object, you might just kind of discount it as not having the thing. So I think it's a tricky thing, because then they're also relying on education and teaching people about durable objects and how they work, because they are very different. What I would say though is, for some data, D1's always going to be better. I think particularly when it has read replicas, because of the nature of them. Durable objects, when they're created, they exist in that place. So if a request comes into your worker in Europe, that durable object will also live in Europe indefinitely. So even if we were communicating via a durable object, it would either be in Europe or it'd be in the US. And with D1, once they have read replicas, right, you're going to have lower latency. So yeah, if you have stuff that's, you're not going to breach the limit of D1, I would definitely reach for D1, particularly when they have read replicas. But if you do need that global coordination, and there is a lot of stuff that needs that global coordination, right? Like you think we're talking multiplayer in Discord, but Google Docs, for example, right? You can see where people's, or like Miro, all these tools, you can see where people's mice are in real time, where they're clicking, the typing in real time, right? There's so much real-time stuff that's really tricky to coordinate. And that's why there's only one durable object, or one instance of that durable object at any one time, is to enable this kind of global kind of communication.
And has it been stated by Cloudflare themselves that there will never be the equivalent of a read replica? This will be a single instance?
For durable objects?
For durable objects,
yeah, I think it's by design. So I've never seen anything about read replicas, because I think it's one of those things where it's there to enable global synchronization across many clients. And it's also designed to remove some of the problems you have with that. So it's single threaded, for example. So if you have multiple requests come into it, they will be queued. But then that removes the problem of things like transactions and, multiple writes happening in different places and all that kind of stuff. So there are benefits to them, and they do have, even though it's single threaded, they can go up to 1,000 requests a second. So they're by no means small. They're small and mighty, I guess I would say, in nature.
Yeah, I mean, that also may help people make a decision in terms of when they make sense, because I'm assuming if you're single threaded, even if you have a read heavy workload, at some point you're going to hit the ceiling, depending on how your application is designed.
Yes, but I think because they're designed to be split in whichever way is sensible, I think you'd have to get to like enormous scale before you hit that problem. Like you can imagine even the most busiest of Discord servers, right? They're not that busy. I don't think I've ever been in a Discord where it's 1,000 messages sent per second. I'm sure there are some crazy ones during like sporting events, maybe, where there are super high messages, but 1,000 requests a second is a lot, right? Even if I watch like a live YouTube video, right, and you have the live chat on the right and it's like flying through messages, it's still nowhere close to that, right? Maybe at like unbelievable scale, you might hit that limit, but I think it's definitely one of those things where upfront you need to decide a good partition. You can't just have one durable object for your entire application, right? You need to split it by user or channel or, some kind of sensible thing. And then I think you'll be fine for a very, very long time.
Yeah, I mean, if you take an example of, say, a corporate Slack server, then I could see maybe the entire business as a whole, maybe there's 1,000 messages going through a second. But then if you scope it down to per channel, for example, then it would be much less. So I suppose that's all a part of your design and, like you mentioned, how you partition or how you choose when to create durable objects.
Yeah, exactly. It's similar to even if you weren't using durable objects, right? It's how you partition your data. And that's one of the most important decisions you can make up front is how you create your database tables, how they link together and all that kind of stuff. So yeah, it's kind of good engineering still applies.
Tying all these things together, can you give an example of a project you've worked on with Cloudflare and how all those services connect and what you used?
I have a few. I think one of the ones I've been working on at the moment is, AI is all the rage. And I was building effectively what's like a RAG pipeline. So you can imagine you're building something with AI and you need to do some RAG, which for anyone not familiar with effectively is like retrieving like relevant context before you prompt the LLM and you're passing it some relevant context. And to do that, you kind of pass let's say the user's query that they've typed into, let's just say a chatbot, and you want to retrieve all the relevant sources that you've stored somewhere, right? That you've built over time. And then you want to pass that to the LLM so it has more contextual information to help answer the query. And on the face of it, it sounds quite simple. You have some data and you just need to retrieve it. But there's actually quite a lot of moving pieces. And I think I found that the ones on the market, there were some like good ones, but I think it's one of those spaces where there's a lot of room for people to kind of go in and do it. So I thought I just want to try building them. And in terms of what you need to be able to create kind of logical databases, if you like knowledge bases. And effectively, each one for me was a durable object. Users can upload files. So let's say this is basically the information that you're giving, like the knowledge you're giving to the AI. And those can be in like Markdown, CSV, PDF, all sorts of formats. So you need to have something that handles all of those. But you could just store that on R2, the equivalent of S3. And then Cloudflare, we've talked about the main products, but they have a vector database called Vectorize, which does exactly what it says on the tin. You basically give it an embedding, which is like a mathematical representation of your data, and you give it to a vector database. And then you can query it and say, give me all the similar kind of pieces of text based on the input query. And then I tie all these things together with a workflow because I need to retrieve each individual document. You need to be able to kind of separate it because the document could be hundreds of pages long. And obviously you don't want to insert 100 pages in one go. You might want to separate it into like 200 character chunks or 1,000 chunks or whatever. Then you need to generate those embeddings that I was talking about using an embedding model. And somewhat surprisingly, we haven't talked about AI at all, but Cloudflare does have an AI product called Workers AI, where they run their inference globally. So in all the places your worker can run, I'm pretty sure that they also have GPUs that run a number of like open source models. They don't have any of the big ones like Anthropic, OpenAI or anything like that, but they do have the Llama models, they have a DeepSeek model and stuff like that, and some of the open source embedding models as well. So I use that as well. And then once you've generated the embeddings, you need to insert them into the vector database. And then after that, because you've chunked the document, you then need to store each chunk somewhere. Each chunk goes into the durable object effectively, and all these things tied together. So it's probably the project I use that uses the most amount of Cloudflare services. The other one that's a lot simpler and maybe a bit easier to grasp because there's lots of moving parts in that one is I'm quite into like my esports. So like competitive gaming, and me and my friends, we all play League of Legends for anyone that plays. And we also like watched esports, and we were kind of wanted the schedule of the games. And we also wanted to know when the games were happening live because sometimes we'd forget. So I built a Discord bot where it scrapes the content off the official website. It pulls out in the schedule. And it also takes like screenshots of the standings that you can get. And most importantly, it runs the worker on a 5-minute schedule. So you have crons that are available like you're used to, and it just spins up the worker every 5 minutes. And it basically checks if there's a live game. And if it is, it posts like a thread on Discord that says, hey, there's a game happening. And then people just jump on and chat about the game. So that uses a few different ones. Like I said, like it uses worker, it uses D1. The scraping, like we haven't talked about it, but they have a product that's basically like Puppeteer as a service called browser rendering, where you can basically browse websites programmatically and scrape and screenshots and stuff. So yeah, those are probably a couple.
You mentioned the languages you can use, and you've mentioned the different services they have. In your experience, when you write, like let's say your JavaScript or your TypeScript code, is the majority of it agnostic to the platform? I mean, outside of the interactions with the specific services, do you feel like you have to write code that's specifically for Cloudflare, or is it more that there's still large parts of your code that if you needed to move to another platform, you feel like you could?
I think by and large, the vast majority of the code you write will just be like vanilla TypeScript or vanilla JavaScript, or obviously you might use packages, right, from NPM or wherever you want to get them from. But because at its core, it's the same runtime that runs in your browser, or in some cases, like I said, Cloudflare has ported Node compatibility, but obviously Node is a very well-known runtime. It's almost like a smaller runtime than, let's say, Node, for example. If you want to take this and run it somewhere, let's say Lambda, that is full Node, it's much easier than doing the reverse, right? So I think that's also one of the challenges of if you do run a full Node environment, you can move it to Cloudflare and you can be like, oh, this library isn't available, so it doesn't work, right? Which happens a lot less now because, like I said, they've expanded the compatibility. But it's a lot safer, I guess, to go from something that's more kind of niche or condensed. And that makes it easier to move it elsewhere. There are things like the bindings, right? Those are entirely proprietary to Cloudflare. So those would cause you a problem. I think if it were me and like if I were building something that I wanted to stand the test of time, I'm going to write it in a way where, let's take the ports and adapters like Architecture Pan, right? Where you basically encapsulate anything that's external to your application is encapsulated in an adapter. So let's say you're talking to D1 or KV or whatever it might be. I would wrap it in a class and then all communication goes via that single class. And that way, let's say I want to move, right? I'm not happy for whatever reason. All I have to do is change the code in that adapter. And because I'm returning objects that are agnostic of Cloudflare, of course you have the data, right? You have to move the data. That bit's going to be the tricky bit. But the actual code, as long as you're doing it in a way that is, there's good engineering practice in there, I think you can limit the blast radius of the impact if you had to move. And like I said, the core of it will absolutely be movable because it's like writing JavaScript in your browser.
As we wrap up, if somebody wants to get started with Cloudflare, you have a book. How do you recommend they get started?
So if you want to get started, obviously, my book will be a great introduction. So you can get that directly from the Pragmatic bookshelf. That's an ebook. And it's also available from Amazon and all the kind of big book retailers out there. I think it covers everything we've talked about. So all the services we've talked about, workers and everything like that. The docs on Cloudflare's website are pretty good. They've just rewritten a lot of them. So if you don't want to buy the book, then absolutely read the docs. There are a ton of tutorials on there that are great to get started, lots of code. Cloudflare themselves have a YouTube channel, but they're slowly adding more things on. I think if you want to see, I think it's one of their DevRel people go through, I think it's like an hour-long video of like a Workers 101, I think it's called. And that's a really good primer on getting started with Cloudflare. And outside of that, like I mentioned, if you're the kind of person that just wants to learn by hacking and slashing something away, you can go and sign up for a free account right now. You'll get access to everything I talked about, apart from durable objects, and there might be one or two more that are exclusively on the paid plan. But yeah, you can spin up a worker, use D1, use workflows, whatever it might be today, and then just get learning yourself. And also, if you do get stuck, like I said, you can reach out to me. Or there's also the Discord, which there's like 70,000 engineers are on that Discord, and everyone's really helpful. It's like a really nice community where people post, I'm stuck with this, and people will reply and happy to talk about things. So that's also a good way to get into the community, I think.
And if people want to reach out to you, how do they find you?
If you want to reach out to me, you can find me. I think the easiest one is probably on X, and I'm _Ashley Peacock.
Ashley, thanks so much for chatting with me about building apps on Cloudflare.
No, thank you. It's been fun. I really enjoyed our conversation. So thank you.
This has been Jeremy Jung for Software Engineering Radio. Thanks for listening.
Thanks for listening to SE Radio, an educational program brought to you by IEEE Software Magazine. For more about the podcast, including other episodes, visit our website at se-radio.net. To provide feedback, you can comment on each episode on the website or reach us on LinkedIn, Facebook, Twitter, or through our Slack channel at seradio.slack.com. You can also email us at team@se-radio.net. This and all other episodes of SE Radio is licensed under Creative Commons License 2.5. Thanks for listening.